This is Hu-Shan Water Purification Plant under Yunlin Water Treatment Plant, governed by the 5th branch of Taiwan Water Corporation, which is located on Pizhutou Farm to the east of Doliu City in Yunlin County. It borders Doliu Industrial Park and the Meilin River, covering an area of 46.59 hectares. In the past, it was a sugarcane plantation owned by the Taiwan Sugar Corporation. The use of groundwater sources for regional industrial development in Yunlin County is a factor causing land subsidence. Land subsidence has seriously affected national land conservation and public safety. In conjunction with the construction of Hu-Shan Reservoir, water purification plant has replaced groundwater sources with surface water sources, thus contributing to the utilization of water resources and land conservation in Yunlin County. With the change of local economic activities, the government has brought about major economic and humanities construction projects, which have subsequently led to a gradually increasing demand for water. The Water Resources Agency of the Ministry of Economic Affairs has already completed the construction of Hu-Shan Reservoir. Since January 2016, this reservoir and Gigi Weir have been conjunctively used to supply water. They provide a daily water volume of 432,000 metric tons to Linne Water Purification Plant and Hu-Shan Water Purification Plant at most in order to meet the central region's water supply targets, including for Yunlin, Jiayi, and Changhua. Water treated by Hu-Shan Water Purification Plant originates from river water from Gigi Weir across the Chouchui River and reservoir water from Hu-Shan Reservoir across the Qingshui River. As river water from Gigi Weir contains very high levels of silt bearing during the high flow period from May to October every year, preliminary sedimentation is carried out via a pre-treatment basin to remove 95% of silt and above prior to delivering clearer, raw water to Linne Water Purification Plant and Hu-Shan Water Purification Plant under high pressure. During the high turbidity period at Gigi Weir, water from Hu-Shan Reservoir is preferentially used so that the intake of highly turbid water from Gigi Weir can be reduced, in order to prevent large amounts of silt flowing into the water purification plant and lower the load of the water purification equipment in the pre-treatment basin, Linne Water Purification Plant and Hu-Shan Water Purification Plant. Water from Hu-Shan Reservoir is also used in moderation to supplement water shortages at Gigi Weir during the dry season, which lasts from November to April of the following year. Both water resources are used to improve water resource utilization efficiency. Raw water means untreated water. When raw water enters the water purification plant via an aqueduct, a series of treatment processes are carried out to purify the water and improve its quality. Next, the journey of water droplets will guide us through the water purification process at Hu-Shan Water Purification Plant. Water purification consists of 4 steps: coagulation, sedimentation, filtration, and disinfection. Raw water enters the regulation basin to reduce flow velocity, so that heavier sediments in the water settle. However, the water still contains small impurities and other suspended particles. Before entering the flash mixer, sodium hypochlorite is added to inhibit and kill algae and plankton in the water, as well as prevent algae from breeding on the rapid filter. Afterwards, the ferric chloride coagulant is added and thoroughly mixed with impurities by flash mixer. Since ferric chloride is positively charged, which neutralizes the negative charge on the surface of impurities, so that impurities do not repel one another electrically to coagulate into bigger flocks. Here we are at the flocculation tank, commonly known as the slow mixer. The flocculation tank is divided into 3 zones by action speed from fast to slow. The odds of collision between flocks increase during the stirring process. Thus, flocks coagulate into even larger flocks. Next, we enter the sedimentation basin, which has a rectification wall. After passing through the sedimentation basin, larger particles slowly sink to the bottom as water flow slows, and the kinetic energy of the floc molecules in the buffer zone decreases. The inclined pipe at the back section of the sedimentation basin allows smaller flocks which float in the water to move upward with water flow, and then stick to the surface of the inclined pipe. The number of flocks sticking to the surface of the inclined pipe increases with time. Upon reaching a certain size, these flocks will settle and sink to the bottom of the sedimentation basin. The sludge scraper scrapes off the sludge at the bottom of the sedimentation basin for the next stage of wastewater treatment. Impurities are deposited to the bottom of the sedimentation basin, while the cleaner water moves upward along the inclined pipe and flows to the rapid filter through the water collection lateral canal. The filter bed in the rapid filter, which is made up of quartz filter sand according to particle size, enables water to gently flow downward. The filter sand layer can block most fine suspended matter in the water. Clean water is then delivered to the clear water reservoir, but disinfectant, i.e. sodium hypochlorite, is added first. The produced chlorate ions penetrate cell walls of bacterium to kill the remaining bacterium, viruses, and amoeba in the water. The chlorinated water remains in the clear water reservoir until the disinfection process is completed. Besides, a residual chlorine meter is installed at the water outlet of the clear water reservoir to check the quality of the water in the water purification plant in real time, in order to ensure the safety of water supply. This chlorine disinfection method has several advantages, including the use of fewer chemicals, the lower cost, and the ability to produce residual chlorine for continuous sterilization. It is currently the most widely used method. These water purification procedures turn raw water into tap water that meets drinking water standards and is safely delivered to users. The water purification plant is located at a higher altitude to maintain appropriate water pressure so that the tap water flows to the water distribution area at a lower altitude by the law of gravity. Doing so significantly reduces electricity consumption for environmental protection. Tap water from Hu-Shan water purification plant is delivered to various boost stations in Yunlin, Jiayi, and Changhua, and is then distributed to various water supply areas. The sludge scraper at the bottom of the wastewater sedimentation basin gathers sludge in the sludge pit, and then sludge is discharged to the sludge pool through airlift sludge removal. The filter layer in the rapid filter gradually accumulates impurities. However, the filtration effect will decrease after a long period of time, which requires backwashing. First, air washing is performed using high air pressure to disturb filter sand and break the film made up of accumulated impurities. Then, the filter sand is washed with high water pressure to peel off the broken impurities and discharge them into the wastewater regulation basin in order to restore the filter layer's efficiency. Wastewater from the rapid filter is left to stand in the wastewater sedimentation basin. After sludge is scraped off, sludge and wastewater from the wastewater sedimentation basin are delivered to the sludge pool. The first and second stage thickeners and the sludge drying bed are repeatedly left to stand. In each process, supernatant is collected, repeatedly recycled, and delivered to the distribution well. Then, it is mixed with raw water to repeat the water purification process. The heavy concentrated sludge from the final stage is discharged to the sludge drying bed for natural solarization. Since chemicals have been added to the sludge after the water purification process, the sludge is categorized as industrial waste according to the Environmental Protection Administration and thus cannot be disposed of at will. A professional manufacturer must be commissioned to convert the sludge into recycled green building materials that fulfill the principles of the 3 Rs, namely reduce, reuse, and recycle, through technical processing. These materials are widely used in red bricks, pedestrian walkway blocks, grass blocks, and permeable concrete pavements, among others, thus enabling resource reutilization. A small drop of tap water goes through these complex processes just to reach us. Yet we often take the convenience we enjoy and the preciousness of water resources for granted. The geographical and seasonal distributions of rainfall in Taiwan are extremely uneven. Drastic increases in river water levels are observed during typhoons and torrential rains in the high flow period, while the dry season is prone to regional and seasonal droughts, thus making it difficult to develop water resources. With deterioration of raw water environments in recent years, accessing clean water resources is growing more difficult. Due to social and economic development, the daily water consumption per person has increased annually, but water resources are not inexhaustible and not always available for use. A serious crisis will emerge when water becomes scarce. Therefore, water education is an important task today. A modern water purification plant should take into account ecology, conservation, and education. As for hardware design, Hu-Shan water purification plant is divided into the independently operated South plant and North plant in order to serve as backup sources. A solar power generation system is installed above the clean water reservoir for effective energy use. The plant's administrative building meets the Silver Class Green Building specifications. The water plant has already passed various environmental inspections and undergone greening works. Noise, air pollution, plants, and animals, and other ecological monitoring are conducted at the construction site every month, according to the Environmental Impact Assessment. At present, the water plant has obtained the ISO 14001 Environmental Management Certification for achieving sustainable management. As for environmental education, greening works are carried out on protection forests around the water plant, while the habitats of farmland green tree frogs, fireflies, and rhinoceros beetles are restored. Besides, various plants such as Kusu eupatorium, bloodflower milkweed, star cluster, and West Indian lantana are planted in the park, which demonstrates biodiversity with a wide variety of plants and blooming flowers. An Environmental Education Center application has been submitted to the Environmental Protection Administration for the certification of environmental education facilities set up in the water plant. This center includes a briefing room, models of water purification equipment, 3D animations, and an environmental education exhibition area, and regularly holds drawing contests, all in order to provide the public with environmental education and guided tours. The content of the guided tours is lively and interesting, so that the public can learn more about tap water and water conservation. Hu-Shan water purification plant covers an area of 46 hectares, with 15 hectares of surrounding land reserved for protection forests, where a large number of evergreen conifers and shrubs are planted and greening works are carried out. In hopes that this area will become like Dolio Runwen Park, considered the lungs of Dolio and the backyard of Dolio City. In the future, this area, along with Hu-Shan Reservoir, fairy pittas, and purple crow butterflies in Huban Village, Lin Mei Township, and other famous tourist attractions in the surrounding area will enhance local prosperity and create new opportunities for Unlin's tourism industry. We hope that everyone can practice these practical methods for water conservation in their daily lives. 1. Turn off the tap to stop wasting water when not in use. 2. Use dual flushing toilets to save water. 3. Take showers instead of baths. 4. Water plants by reusing water from washing rice and vegetables. 5. Wash your car by using a bucket of water instead of the hose. It can save up to 180 liters of water each time. 6. Select toilet bowls, water taps, shower heads, washing machines, and other water-saving products affixed with the water efficiency label. Water is the source of life. From rainwater flowing through rivers to water intake facilities, raw water is treated to produce tap water for us to use. Water is a precious blessing of nature, as well as the outcome of contributions and efforts from countless people. Water conservation should not only be to respond to water shortages, but also to protect the environment. To cherish water resources is to cherish the future of generations to come.